Hello, everyone. So for this session, I'll be discussing the implementation for model-agnostic methods. So as usual, I'll be importing the libraries, and then I'll be preparing the dataset, which in this case is the Titanic dataset. And then I'll be doing some of the pre-processing, such as imputation and train test split. So there are two approaches for doing model-agnostic methods. There's the global and the local one. Let's start with the global model-agnostic methods. And again, we use that for models that are not inherently interpretable. So one approach for global model-agnostic methods is answers the question, what features have the biggest impact on predictions? Permutation importance is a method for measuring the impact of a feature on the model's predictions. This is done by randomly shuffling one feature's values and observing how much this disrupts the model's performance. This is a more specific example of sensitivity analysis, and that's normally the term that we use in other fields. But in the context of machine learning, it's permutation importance. But if you hear sensitivity analysis out there, it's the same thing. So the process for that is you train the model, whatever model that you have, and then you shuffle the features values and measure the drop in performance. And then you restore the original features values and repeat the process for other features that you have. The more a model's performance drops after shuffling a feature, the more important that feature is. So in this case, I'll be using random forest classifier. Then I'll train the model, and then you can see the score here, and then I'll apply feature importance. Good thing there's a function in scikit-learn for feature importance. So you could plug in the model here, and then you can see the importance of the different features. So in this case, since this is the Titanic dataset, you'd expect that it's this X that has the highest predictor component in this model. So if you have a high sex male value, which in this case is a male person, then that means you have the most importance, and that actually decreases the survivability of the specific data point. So this is the visualization for that. You see the sex male P-class fair having the highest importance. You could also see the spread. So this is the decrease in accuracy score. So how to interpret that? Yeah, as mentioned, the most important features appear at the top. The values reflect how much shuffling each feature affects the model's performance. In some cases, negative values will occur, but that's due to randomness. And that happens often in small data sets due to chance. Another approach for global model agnostic method is partial dependence plots. It's for visualizing the relationship between a feature and the target. As usual, we hold all other features constant. They help answer questions like how does changing one feature while keeping others the same affect the prediction. So the process for that, I would say, is quite similar to hyperparameter tuning. So you select the feature first that you want to analyze, and then create a value grid like hyperparameter tuning, generate a list of values, a range of values for that feature, and then you make predictions based on the different values for that specific feature, and you observe the performance, the changes in performance for that specific feature. And then you average the predictions, and then you visualize and interpret. So you could do that as well using sklearn, and you could see the different impact on performance in the age feature. So you can see that it generally drops if you have a higher age. You could also do it for 2D. So instead of just one feature, like age, could have age and then sex. So you could see the impact here. In this case, in the graph above, the lighter hue indicates better performance. We can see that if the passenger is female, not sex male, and the age is lower, then you have the highest chances of survival. Could try it for other features as well, like sex male and fair. Same idea. Passengers that have higher fare and are female have higher chances of survival. This part is not so obvious, So in some cases, it's quite tricky to use that, but the same concept still applies. So in this case, it's fare and age. Again, it's not as straightforward, but generally the passengers that have higher fare and lower age are likely to survive. Now let's proceed to local model agnostic methods. So we could use SHAP for that. It answers this question. So what if you want to break down how the model works for an individual prediction? So SHAP or Shapley additive explanations values provide local explanations for individual predictions by showing the contribution of each feature to a model's output. So you're gonna have to make use of another library for that. For demonstration purposes, let's just use one data point. So in this case, it's 5, right? And then let's predict the probability of survival. Now let's use SHAP. So you've seen earlier that it's 96.25% chance of survival. But why? So we could use tree explainer here because it's a tree-based model. I'm gonna show other ways of doing explanation later, but for now it's tree explainer. And then you use SHAP, so it's just 2 lines here. You plug in the values and it shows you the impact of different features to our output, which in this case is 96%. You can also see the base value here, which is between 0.3 and 0.4. So because of these features, we got the 96%. So lower sex male value, which is 0, that means female, increased the chances of survival by a lot. Then followed by P class here, then fair, then low age, quite young. There's also the Parcas, which decreased survival just by a little bit. But basically, with all these features combined, you have the 96%. Again, as mentioned earlier, the top features are sex, male, P class, and fair. And that's those are the main reasons why we got that survival rate. Now we could also do that for multiple data points, and this is the code for that. You might have to use a different view for you to be able to visualize it properly. And if you run it using your notebook, you could better see this. I used my personal notebook for this, so if you use Colab, you will see this. But if you run using your notebook, you will see this. And also, it would be better if you use light mode for that specific viz. Now, what if you want to have an overall view for the model instead of just a specific data point? You want the whole data set. So you could also do that using SHAP summary plot. So you could see the visualization here. And there's a guide to interpret this. So the vertical position indicates which feature it represents, right? So this one, sex male P class fair, the color shows whether the feature's value is high or low for the given row in the data set. So it's this one color here. If it's pink reddish, that means it's high. If it's blue, that's low. And then the horizontal position shows whether the feature's value contributes to a higher or lower prediction. So generally, if you have a high value for sex male, that means male, then you have lower chances of survival, as you can see here, because it's negative SHAP value, and vice versa. And same goes for other features. You could also simply get the average of the impact instead, using this SHAP summary plot, and then just plug in these values. But we used tree explainer earlier. What if you want to explain other models? You could use kernel explainer. Still the same concept, but it basically simulates the model. So it's not exactly the same thing, but more or less you're gonna get the same explanation, and it's a bit slower because it's an approximation. So you could use this same visualization. You get more or less the same output. If you observe carefully, you will see some changes, but it's generally the same if you use kernel explainer. And for the ranking, it's still the same. I mean, the ranking of the feature importances. And that's it.